This is my page 11. Good. Okay, so average profit. Okay, so I got an example right here. R of x equals 50x. C of x equals x to 2/3 plus 750. And they want us to find the average profit. That's what we wanted to do. Okay. So first, in order to find the average profit and the rate of change of the average profit, first I have to find the profit, which is the revenue minus the cost. So then the profit equals revenue, 50x minus x to 2/3 minus 750. Remember, we subtract the cost, which means I have to subtract everything in the cost, not just pick and choose. Okay, so now I have to find the function this, which is the average profit. So when I find this function, 50x over x is 50. X to 2/3 over x is x to 2/3 minus 1 minus 750 over x can stay as 750 over x. Now I want to differentiate this function. So p of x divided by x prime, 50 prime is gone. This one, I bring down the power, I get 1/3, x to negative 1/3 minus 1, which is negative 4/3. Now here, I know that 1 over x prime is negative 1 over x squared, but negative 1 over x prime is 1 over x squared. I have negative 1 over x prime. So this is positive 750 over x squared. So I determined the rate of change of the average profit. So this is the average profit. This is the rate of change of the average profit. And now they may ask us to plug in x equals 50 or whatever, and we plug it in. Be careful how you enter this in the graphing calculator. Any questions? Any questions? Yes, I know I still promise. I didn't forget to use the definition of the derivative on a difference quotient, on a rational function. Good. Anything else? We know the definition of continuity at a point. We did that. We know the formula for the compound interest. Please review that. It's just algebra. There is nothing. All these first ones are just algebra and equilibrium point as well. So, yes?
This one question.
Yes?
It is C of x equals, it's average profit, right? So C of x equals 4,300 plus 2.1x to the 0.6 power, where R of x equals 65x to the 0.9 power. Find the average rate of profit per base when charging 50 bases were made, and so
yeah, they're just different functions, and all the procedure is the same.
Okay.
So I chose one example, you chose a different one. Is it clear?
Yeah, it had decimals, so I thought it might differ a tad bit, but if it's the same.
No. Just give me that example. So you're saying that the numerator had x 0.3 and the denominator is x. So it's x to 0.3 minus 1, which is negative 0.7. And when you differentiate x to negative 0.7, you bring down negative 0.7 and you subtract 1 from the power, negative 1.7.
Oh, okay, cool.
We had an example in the class, I think, like this one.
Okay.
Is it better now?
Yeah.
Okay, perfect. So anything else from here? Are limits okay? So we had one more question. I promised to look at, so any rational function, can anyone give us a rational function so we can look at the definition of the derivative for a rational function? Anyone? Okay, 1 minus x over 2 minus 2x minus 3. So we want to find the derivative not with differentiation rules. It doesn't matter what the problem is saying. I'm going to find it with differentiation rules so I know what to expect. Okay? On my scratch paper, I can do whatever I want. So I would definitely make sure that I get the correct answer. But what is the definition again? The definition of the derivative. And how do I start? So we want to find the derivative of this function using the definition of the derivative.
Would f prime just be negative 1?
Fine. I couldn't hear you. You're muted, kind of.
Oh, I was just saying, the definition of the derivative is like the difference quotient.
No, the derivative is not the difference quotient. The derivative consists of two major concepts, not one, but two.
The limits.
Ah,
Limit of
h approaches 0 from f of x plus h minus f of x divided by h. Yes. So please remember there is only one definition. We're not talking about the differentiation rules. We're talking about the definition of the derivative. Good. So then this is the limit as h approaches 0 from 1 minus x minus h over 2x plus 2h minus 3 minus 1 minus x over 2x minus 3 divided by h. This is a more complicated situation because of the function. The function is not easy to work with. Good. So then we have limit as h approaches 0. Can anyone give us the least common denominator? Without the least common denominator, I can continue. Can anyone give us the least common denominator?
2x minus 3 times 2x.
Thank you very much. They do not have anything in common. Thank you. Brilliant. Thank you. So then this one needs to be multiplied by 2x minus 3, and this one needs to be multiplied by 2x plus 2h minus 3. That's why this is way more involving because of the function. This is not difficult, but it takes a longer time. So 2x times all these. Watch me run out of room. I always do. So 2x minus 2x squared minus 2xh minus 3 plus 3x plus 3h. Now I have to be careful because I distribute 1 to all these, but with minus. Negative 2x, negative 2h plus 3. And now this is plus now. So plus, I'm going above because I ran out of room, of course. 2x squared plus 2xh and minus 3x. As before, yes, all terms without h must go away. If they don't, I'm in trouble. Maybe more than that, but at least those have to go away. So the negative 3x with a positive 3x, the 2x squared with a negative 2x squared, the negative 2x with a positive 2x, the positive 3 with a negative 3. Luckily, the negative 2xh with a positive 2xh. So what is left from the whole thing is 3h minus 2h. So that's 1h at the top. So this will be limit as h approaches 0 from h over 2x minus 3, 2x plus 2h minus 3, h over 1 flipped. Now the second step happens, lucky us, and now when I plug in 0 for h, I get 2x minus 3 times 2x minus 3. Now, to make sure that my calculations are correct, I'm going to apply the quotient rule on this. If I don't get this, I'm in trouble. So 2x minus 3, squared. The top prime is -1 times the denominator minus the top times the denominator prime, which is 2. Now the moment of truth, -2x plus 3 minus 2 plus 2x over 2x minus 3, everything squared. And yes, I'm recovering my calculation from before, and this is indeed correct. So, I wish we had a little bit more time to cover more of these limits. Reading from the graph, I know you know. So I was hoping to have more of those limits. So here is, I'm going to stop my video now.